Hi, Mr. Pepperell here, and in this video I'm going to be talking to you about fuses, what they are and what we use them for.
So previously we have talked about plugs, and we've talked about cables, and in particular we talked about how the earth wire, the yellow and green stripy one here, protects the user of the appliance from electrocution. Well, today we're going to be talking about the fuse over here. Okay, now the fuse is there for protection as well, but this time it's not to protect you, it's to actually protect your appliance. So the purpose of the fuse is to protect the appliance, not the user. So if we take a little look inside the fuse, we can see that if we, bring it up here and have a little look inside, the fuse actually contains a really thin wire that is used to connect the mains line to your appliance. And that wire is actually in series with the mains live and the live wire of your appliance. So if we have a little look at the circuit there, we can see that we've got our main supply here going to my appliance, which in this case is just a bulb, okay, and the fuse is in series, okay. Now we know that as an electrical current passes through a wire, the resistance of the wire actually causes the wire to heat up. So if we have a little look at a picture here, you can see there's a wire there, there's a current passing through the wire, and it's causing that wire to glow because it is heating up so much. Okay, and in fact a fuse is actually relying on this fact, the fact that the wire is going to get hot. Okay, if too high a current starts to flow in through the live wire of your main supply and through your fuse, if the current is too high flowing through this fuse wire, the wire is going to heat up too much and eventually it is going to melt. Okay, now when a fuse actually melts, this is what we end up with it looking like. Okay, when this happens, we say that that fuse is actually blown. Now it doesn't blow up, it's not an explosion. What happens is the wire has just got so hot there, it's melted through, and when it's melted through, obviously the circuit's not complete, and this disconnects your appliance from the mains and it protects it from that excess current which is flowing. So we can see here that we've got our fuse, and we actually put our fuse what we call on the live side of the appliance. We put it between the mains live wire and the live wire of the appliance. Obviously that's where you want it to be. You want it to blow when the current coming into the appliance gets too high. It'd be no good putting it over here on the way out of the appliance, because by that time the current's already flowed through the appliance and done the damage. Okay, so if we were to actually have a little look at a fuse, we'd see something that looked a little bit like this. Okay, and you'll notice on the outside of these fuses we've got numbers. We've got 13, we've got 3, we've got 5 over there. That's actually the rating of the fuse, and it's shown here, and it's the maximum current that will be allowed to flow through the fuse before the fuse blows, or the wire inside the fuse actually melts. Because obviously the electronics inside every appliance have been built and designed to work with a certain current, and if the current gets too high, well, it can damage that appliance. So if we have a little think about it for a second, okay, if we think about an appliance like this microwave here, so say that plug's joined up to my microwave, we'll join it up, pretend that's the wire there. Okay, so if we chose, say, a 13 amp fuse and we put it inside of our appliance there, but our appliance only requires 5 amps to flow through it. Okay, we've chosen a 13 amp fuse over here in our plug. We only need 5 amps to flow through the appliance. It's going to cause a problem. Okay, if the fuse current rating is too high, 13 amps on here, okay, it's too high for the device. The device only requires 5 amps of current to flow through it. So this fuse is not going to blow. We could start getting 6 or 7 or 8 amps of current flowing into the machine. The fuse is not going to have blown because its fuse rating is 13. The actual appliance only requires 5 amps, so those 7, 8, 9, 10 amps of current are going to damage the machine. And of course, it works the other way as well. If we put a 3 amp fuse into our appliance that requires 5 amps, again we're going to have a problem, because the appliance is trying to draw 5 amps of current, but of course the fuse can only take 3 amps before it blows. So every time you turn the machine on, your fuse is going to blow like that. Okay, your fuse will be constantly blowing because the appliance is trying to draw more current than the fuse can take.
So that is fuses, what they are and how they work. Any problems with that at all, don't hesitate to tweet me at Mr_Pepperell or email me and I'll get back to you ASAP. Thanks for stopping by.